When a sizable earthquake hits, say, California or Japan, people generally don't take note of it too much. It's a thing that happens, and it may startle people there for a bit, but they get earthquakes so frequently that it's not too much of a concern. But what if the same earthquake hit Tennessee? As it turns out, there are plenty of places like this that you would never associate with the ground shaking, but are capable of producing devastating results just the same. Now, before we get into obscure fault lines, I'd appreciate if you like the video, subscribe to the channel, and hit the notification bell to stay tuned for future content. Okay, so to start, let's jump to the Middle Mississippi River Valley, a region that seems tame on the surface when it comes to geological activity, but is nonetheless one of the most dangerous places for earthquakes in the US outside the West Coast. This is because the region sits on what's known as the New Madrid fault line, and yes, it's pronounced that way for some reason, which has been capable of producing earthquakes comparable to what has happened in California. Perhaps the biggest instance of these quakes came in 1811 and 1812, when a series of four earthquakes, all of them measuring at magnitude 7 or greater, struck the region. For clarification, the magnitude of an earthquake measures just how much energy it releases, and due to it using a logarithmic scale, an earthquake of magnitude 5 releases approximately 33 times more energy than an earthquake of magnitude 4. Anyway, these earthquakes were incredibly strong. The strongest one measured at magnitude 7.5, and the 1906 San Francisco earthquake was only a bit stronger at 7.8. These earthquakes combined to absolutely decimate the region, which at the time was only just starting to get settled by Americans moving west. The reason seismic activity even exists at all here is because of a rift that formed over 500 million years ago, known as the Real Foot Rift. If this rift was successful, it likely would have torn apart the proto North American continent and resulted in a far different geological landscape today. Though this obviously didn't happen, in a way the scar from the rift remained underground, and due to the stresses associated with continental drift, the scar can be reactivated in the form of several major fault lines despite it being located deep within the North American plate and far from the tectonic plate boundaries that usually define earthquakes and other geological activity. Because large earthquakes occur so infrequently, scientists aren't exactly sure when or even if it's possible that a similarly powerful magnitude 7 quake could strike in the future. If one did, however, the effects would likely be even more devastating for two key reasons. For one, there is significantly less focus on earthquake preparedness in the region, with far less infrastructure that is built to withstand that kind of earthquake compared to cities in California. This is crucial, since this isn't exactly an underpopulated region. Memphis is located basically right on top of the fault, and St. Louis is located a stone's throw away from it. But it gets worse than that. Compared to seismically active areas like California or Japan, the crust underneath this region is much more settled, which is much more effective at moving shockwaves through the ground. This, in turn, causes these earthquakes to be felt over a far wider area. Take a 5.3 magnitude earthquake that hit southern Illinois in 1968. Despite it not being the most powerful quake ever, it was felt as far away as Pensacola, Florida, and parts of southern Ontario, which is in some places about almost 600 miles from the epicenter. That would be comparable to an earthquake in Los Angeles being felt in southern Oregon or Salt Lake City, which is virtually unheard of. As a result, tens of millions of people would likely at least somewhat feel a more powerful earthquake in the fault, even if not necessarily the strongest shaking. Now, let's make a quick jump out east to New York City. Unlike the second largest city in the nation, Los Angeles, the Big Apple isn't necessarily known for its earthquakes. So that's what made it all the more surprising when, on April 5th, 2024, a magnitude 4.8 earthquake struck in northern New Jersey, causing it to be felt across the New York City metropolitan area. This was the biggest earthquake to shake the region in decades, and it led to numerous reports of swaying buildings and minor damage. The last time an earthquake had severely affected the region was back in 2011, when a 5.8 magnitude earthquake hit Virginia. Because of the aforementioned differences in crust structure allowing for the earthquake to be felt further away, this caused significant shaking to occur even as far up the coast as New York City. The largest earthquake to directly hit the city happened way back in 1884, when an earthquake of roughly magnitude 5 hit either near or just south of New York City. The effects were similar to the one that happened a few months back, with reports of falling bricks and other minor damage being found up and down the East Coast. But why exactly does New York City get earthquakes on rare occasions like this? Well, the reason boils down to something similar to what is seen in Missouri, but on a smaller scale. Simply put, ancient geological processes have leave scars in the crust which never fully heal and can get triggered by small stresses in the crust. In particular, there are several minor fault lines in the region, with perhaps the biggest one being the Ramapo fault line that runs through eastern Pennsylvania and western New Jersey. Some studies have suggested that a magnitude 6 or even 7 earthquake could originate from faults like these, which, given the lack of earthquake preparedness in the region combined with the extreme distance that such earthquakes would be felt at, would almost undoubtedly cause catastrophic devastation across numerous states and paralyze much of the Northeast and Mid Atlantic. Okay, so zooming out a bit, think about which continents tend to get earthquakes in the first place. Both of the Americas, Eastern Asia, and most of Australia and New Zealand lie on the Pacific Ring of Fire, so they're hotspots for earthquake activity due to the fact that the Ring of Fire itself is caused by a tectonic plate boundary. Europe is less talked about when it comes to earthquakes, but some places, especially in southern Europe and Iceland, do get slammed from time to time. That leaves Africa, which is a continent that doesn't really experience too many earthquakes. Why is this? Well, this comes down to a few reasons. First of all, while Africa does have its own tectonic plate, its plate boundaries are usually way out in the middle of the ocean, with its western and southern boundaries helping to create the mid-ocean ridges that circle the globe. In the north, it does border the Eurasian plate, but that plate boundary is actually located on the north side of the Mediterranean for the most part, which helps to drive the earthquakes in southern Europe. To the east, you have the Arabian plate, but this plate boundary is much more stable and doesn't move around a whole lot, and it's that movement that causes most earthquakes in the first place. When all of this is put together, continental Africa is well protected from plate boundary earthquakes, but what about those underground scars and fault lines that I mentioned before? Well, on the whole, Africa is a much larger and older continent than most other continents on Earth. This, in turn, has allowed for more time for ancient geological risks to heal and not really cause problems down the road, as these events happened much further back in the past. There is, however, one major place that Africa experiences tectonic activity, and that's in the East African Rift Zone, which I actually mentioned in my last video about really old lakes. As I mentioned back then, this is basically a continent that is splitting itself apart, and the act of doing so creates ripe conditions for tectonic activity. Most of this has come in the form of volcanoes, such as Mount Kilimanjaro and Mount Kenya, but earthquakes can and have happened from this movement, and the volcanoes themselves can cause earthquakes due to how forceful the movement of magma underneath the crest can be. And that's all I got to say about weird earthquakes. As always, I'd appreciate if you like the video, subscribe to the channel, and hit the notification bell to stay tuned for future content. Thanks and have a great day.